Imagine waking up one morning and hearing the news. A massive asteroid, bigger than a mountain, is heading straight for Earth. The date of impact is known. The world has months, maybe only weeks, to react. Could humanity actually stop it? Or are we helpless against the kind of cosmic event that once wiped out the dinosaurs? For most of human history, the answer would have been no. But today, the story is changing. Science, technology, and global cooperation are giving us tools that, for the first time in history, could let us fight back against a planet-killing rock. Let's start with what we're up against. Every day, Earth is bombarded by about 100 tons of small space debris, tiny rocks that burn up harmlessly in our atmosphere. But larger asteroids, a kilometer wide or more, are a different story. If one of those hit Earth, the energy released would equal billions of tons of TNT, enough to destroy entire continents, send shockwaves through the planet, and cause a global winter. This isn't science fiction. It's happened before. 66 million years ago, a 10-kilometer asteroid slammed into what is now Mexico's Yucatan Peninsula. The impact vaporized everything for hundreds of miles and filled the sky with dust, blocking sunlight for months. That's how the dinosaurs died, not because they were weak, but because nothing on Earth could survive that kind of catastrophe. The good news? We're not dinosaurs. We have telescopes, rockets, and time. In the last few decades, scientists have been working to identify potentially dangerous asteroids. NASA's Planetary Defense Coordination Office, yes, that's a real thing, scans the skies every night, tracking over 30,000 near-Earth objects. They use telescopes like Pan-STARRS and the Catalina Sky Survey to find new ones before they become a threat. The key word here is before. If we find a dangerous asteroid years or ideally decades in advance, we have options. There are several proposed methods to deflect or destroy it, depending on its size, speed, and composition. The first and most realistic approach is the kinetic impactor. That's exactly what NASA tested in 2022 with the DART mission, the Double Asteroid Redirection Test. They slammed a spacecraft, traveling at over 20,000 kilometers per hour, into a small asteroid called Dimorphos. The goal was simple. Hit it hard enough to change its orbit just a little bit. And it worked. The impact shortened Dimorphos's orbit by about 33 minutes. Proof that with enough warning, we can nudge an asteroid off course. Another idea is the gravity tractor. Instead of crashing into the asteroid, a spacecraft would fly alongside it for months or years, using its small gravitational pull to gently tug the asteroid into a safer orbit. It's slow, but incredibly precise, like steering a giant rock using patience and physics. And then there's the nuclear option. Literally, a powerful nuclear explosion near an asteroid's surface could vaporize part of it, creating a jet of material that pushes it off course. It's risky, because if the asteroid breaks into pieces, we might end up with multiple smaller impacts instead of one big one. But in a desperate last-minute scenario, it could be humanity's only chance. Of course, all of these methods depend on time. A few decades of warning means we can plan, build, and launch a mission. A few years means we'd have to act immediately. A few months? That's when things get terrifying. Even with our most advanced rockets, there's only so much we can do in a short time. So, how prepared are we really? As of now, astronomers have identified about 95% of the large near-Earth asteroids, those big enough to cause global catastrophe. None of them pose a threat for at least the next century. But smaller ones, big enough to destroy a city, are harder to detect. The 2013 Chelyabinsk meteor, which exploded over Russia and injured more than 1,000 people, was only 20 meters wide, and no one saw it coming. That's why new missions are in development. NASA's NEO surveyor, launching soon, will scan the sky in infrared, helping to detect dark, hard-to-see asteroids before they surprise us. The European Space Agency's Hera mission will study the aftermath of DART's impact to improve our future defenses. Humanity is building a global network of planetary defense, something the dinosaurs never had. But even with all our progress, there's one thing that still matters most: global cooperation. An asteroid threat isn't a national problem, it's a species problem. No single country can defend Earth alone. If we ever face a real impact threat, we'll need governments, scientists, and engineers from around the world working as one. So, can humanity stop a planet-killing asteroid? The honest answer is not perfectly yet, but for the first time in history, we have a fighting chance. We've learned how to detect danger. We've proven we can move an asteroid. We're building the tools to protect our planet. And maybe, just maybe, when the next great rock comes our way, humanity will be ready. Because this time, evolution won't be about survival of the fittest. It will be about survival of the smartest.